Refraction lab. Today we did the refraction lab. It was on light refraction. The aim of our lab was to find the refractive index of perspex. Using perspex, an array of light, we experimented with various angles of light and how large the angle of light was bent after passing through the perspex block. We found that the angle of incidence, I, the angle pre-hitting the block, is always higher than the angle of refraction, R, the angle of light after passing through the block. The relationship between the two signs can be written as y equals m times x plus b. X is the sin of R and y is the sine of y, and m is the refractive index of the acrylic block. This is described in Snell's law. Steps for the lab were quite simple. First, you trace around the block and create a ray of light halfway along the block that would be our normal light. Next, you would penetrate the block with another ray of light in any way as long as the light went through the normal, and then trace the lines of the light. After that, you measure the angle of incidence, I, and the angle of refraction, R, and record the data in a table. Materials. We use 5 simple materials: a ray box, perspex blocks, protractor, computer to put in data, and a pencil to trace the light rays on the paper. Graph. As mentioned previously, you can see in our graph the relationship between sine I and sine R. Sine I over sine R is equal to the index, velocity of the light through the block, which is our slope. The slope of the graph is 1.3806, which is the refractive index of the block. Refractive index is the velocity in which light travels through the medium, in this case, the block. There are many examples of refraction, as long as there is a wave, usually light, that lowers its velocity as it enters a denser medium from a less dense medium. It is a refraction explainable by Snell's law. One example is the refraction of light when enters water from air. Air has refraction of 1.003, while water has refraction of 1.33. If an object is placed, slanted, in water, and a person looks at it, it appears straight, because the light reflected from the object bends the denser medium, water, to the less dense medium, air. Another refraction is the rainbow, which appears on the sky, as well as when light is split by a prism. Because glass is a higher density, therefore a higher refractive index, than that of air, the different waves in the light changes directions, creating angles, thus resulting with the 7 different colors of the rainbow.